I'm Harini R. Finally, a biomedical student. I'm working on the project of about heart attack detection of rapid miner. Rapid miners open source dataset science platform that provides an integrated environment for the data preparation, machine learning, and deep learning. It is to users to design, train, and deploy machine learning models without requiring extensive programming knowledge, and it mainly used to key features of rapid miners drag and drop interface, pre-built machine learning algorithm, data preparation tools, and deploying and monitoring automated machine learning model. And I am working on the project of about heart attack prediction using rapid miner. Nowadays, heart attack is a leading cause of death worldwide. Early detection of heart attack can reduce fatal outcomes, and from this, I develop a deep learning model to predict heart attack risk based on patient health data. I have fetched the data from the Kaggle data set, and the key features of data set is age, cholesterol, blood pressure, heart rate, and ECG. And the target value of hot is 1 means high risk, 0 means low risk. And then now diagram of the heart attack prediction is first, and then deep learning model is a multi-layer perceptron models take patient health data as an input, and it has three layers: input layer, hidden layer, and output layer. First input layer takes patient health data as an input. Hidden layer is activation function with multiple layer. Output layer is a binary classification with us. Heart attack is yes or no, and it has a loss function which is a binary cross entropy, and it is used as an optimization algorithm is RMS Pro. And then I have 80% of training and 20% of testing. With the model training is completed in 10 seconds in the Alter AI Studio, and data pre-processing, handling missing values and normalization values, and insight and analysis is key observation with detecting high risk of patients, and some misclassification occurs due to overlapping features values. And this is a workflow of the I have predicted the heart disease. First is load and process the data, which is used to retrieve the data from the Google, create single row and pre-processing, and filters examples. Sampling, remember, first we want to load the data into the studio, and the general pre-processing to filter the materials and filter data and create a sample and then save the data, and then come out to create a validation and create a validation set which has a split the data, remember training and validation. Remembering validation, which is used to training the data without texting, pre-processing, or feature engineering. And with and next one is basic feature engineering, which is perform some basic engineering task with the retrieve original data, category values encoded, and store the training data from the before processing, and then using handle text columns, which is used to recall raw training, data transformation training, data text processing model, which is used in the feature engineering. Handle text columns, and automated feature engineering performs a pre-monitorized this is a automated feature engineering. Before starting an automated feature engineering aims to ensure the model or somewhat appropriate to that error, and trade-off between low complexity and low error rates. And then transform validation data. Transform validation data, which is used to hold out validation with robust enhancement. Read staging data on existing processing, existing training, and then matching pre-processing, matching training, or this includes the validate model. And then transform scoring data, which is used to select sorting, scoring, bin scoring, normally scoring, and indicates the type of transformation being applied to the data can be used. And then create a protection model is the used to protect build the model and recall the training data, validation data upon the training and validation in the total protection model, create the standard transformer training data and apply the scoring model to protection model. And then the statistics of the whole result is about minimum standard deviation is 10.6 and minimum of 30 and maximum of 125, and the data points of 141.36 and mean of 68.6 with the total diastolic pressure. And then the result of is about this is the data I have loaded from the Kaggle dataset, and this is the statistical value of age, sex, and total cholesterol, ideal, HDL, systolic, diastolic, smoking, diabetes, and heart attack. Visualization of this with the x-axis with with the x-axis of about total cholesterol and y-axis I have applied as ideal, which is a graph plotted in the scatter plot. And I have already discussed about x-axis total cholesterol and y-axis ideal, and the data points are colored is based on the heart attack attribute. And the conclusion is about an effective tool. Deep learning provides an effective tool for heart attack prediction with the MLP model with a high of 0.81 and good classification accuracy of approximately 91.5, and slight misclassification is according to 8.52. And then the performance matrix mean squared error is 0.0732 and the RMS square of 0.2706 and log loss of 0.2598. And then thank you.